Hi everyone. Today we're going to be talking a little bit more about energy and its conservation, giving out a little bit more examples about mechanical energy, kinetic energy, and going a little bit more in depth. In these times, we're going to be talking a little bit more about work and power, and throughout the video, you're going to hopefully know more than you knew to be in the start of this video. So, to begin with, I just want to talk about what is energy? We see it all the time. It's a really frequent word that we see people using in everyday life. So we normally say, "Oh, I'm so tired," and literally, I'm running out of energy. I have no energy at all. Or we see it when we talk about hydroelectric that's producing some type of energy, or like anything at all. But then, what exactly is energy? Can we really define it into some little words? First off, we have to think about how do we define if something has energy or not? What do we look for when we're looking for something, and how do we define it? We're like, I don't know, I'm completely lost. Does my cell phone have energy? Does my finger have energy? Does, like, I don't know, this calculator have energy? And the simple answer for that is, of course. Everything has energy. So, in general, to define energy, it's just the capacity to do something. Just the capacity to do something. But then, oh well, does anything in life do something? Like, I don't know. The example I just gave about the calculator is just sitting here, but it does have energy. So meaning that an object, in order to do something, it must require energy. For us humans, we get energy through food. And we get energy through the food we ingest. So basically, when you look at something, or when you look at a pack of chips, and you look at the back and you see the label on the back, and you see the amount of calories that there is in that specific bag, it's just the amount of energy there is in that certain food, which is amazing, right? Because I hadn't really thought about that before, but yeah, it's just the amount of energy you're receiving from that. Thinking about it, that means energy is literally everywhere. People need energy to, I don't know, walk, talk, think, breathe, sleep, and many people get it wrong. People say, "Oh, I'm gonna sleep because I'm gonna get my energy back," and that's a really common mistake. Because when we sleep, we're not actually recovering our energy. We actually need energy to sleep. We require a lot to sleep, because our body has to keep our brain active, our breathing stable, and our blood running, as long as many other functions in our body. And during our sleep is when we most need energy. So, from that, we have to move a little bit further and come to a conclusion of the law of conservation of energy, which basically means that energy cannot be created or destroyed. It can only be transmitted or transformed. So basically, this means that if I were to be running right now, I'd be having energy. But where did this energy come from? Basically, how do humans get our energies? As I said previously, we get our energies from food, which means if I don't know, what did I eat this morning? What did I have for breakfast? I think I had some, like, a fruit salad, or maybe, I don't know. Anyways, it doesn't really matter. So the fruit salad that I ingested, the fruits that were in it got the energy from somewhere, because I kind of stole the energy from them, right? But in a way, we can think about, where did the energy from the banana, or from the apple, or from the mamon come from? The energy came from the sun. The fruits that were in the salad fruit, were photosynthesized energy, like many other plants do. So they got the energy from the sun. But then you're thinking, how does the sun have energy? And we can explain this by nuclear fusion, which is basically when inside the hydrogen atoms, there's the release of a lot of energy. So now that we got the law of conservation of energy, that states that the energy cannot be created or destroyed, only transformed or transferred, we can move along to, if energy is the capacity to do something, there must be so many types of energy, right? And yes, of course there are many types of energy. But we're not going to be talking much about these types. There are a lot of types of energy, such as mechanical energy, thermal energy, nuclear energy, chemical, sound, electromagnetic, and electrical. But we're going to be like focusing on our target point on mechanical energy. So I feel that we're now a little bit more prepared to move on to the next topic, which is focusing a little bit more into mechanical energy. And we can just imagine that mechanical energy is right there on the top of the pyramid, right there. It's like popping and shining, and then from that there's going to be a bunch of other branches that we're going to see and we're going to talk a little bit more about. Basically, mechanical energy has to do with motion. So it's either the lack of motion or the existence of motion, if you know what I mean. So to begin with, right at the top of the pyramid, mechanical energy, the capacity to move. Then let's pretend we make two arrows, so we're going down the pyramid, okay? So from one side we have kinetic energy, which is when the object is already in motion, and in the other side, which is potential energy, which is when something is not yet in motion. So if I have this object right here and it's still right there, it's potential energy because it's not doing anything. But if the object were to fall like this, then it's kinetic. Got that one? Okay. So it goes it gets a little bit harder than that. So remember that right now it's mechanical, then from one side, kinetic, the other side, potential. From the potential side, now there's two other possible potential type of energies, which is gravitational, and then the other side is elastic. So gravitational is due to gravity. So why is the object falling? This object is falling from right here because of gravity. And in the other side, which is elastic, it's due to elastic force. So a spring or something related to that. You know what I mean? Okay. So I feel like you guys can have a really solid idea. This is sort of what it looks like right here. You can have like a visual portrait of what it looks like. So as I said, mechanical is right here, then kinetic, potential, then two types of potential, which is gravitational, which is affected by gravity, and then elastic, which is affected by an elastic force, which can be a spring, and most of the time is a spring. For kinetic energy, we know that the object is already in motion, and we can say that from now, because it depends on the object that's already in motion, it depends also on the reference point. So the factors that influence kinetic energy is mass and velocity, and we could say that the mathematical equation for such is K, which is kinetic energy, equals 1/2 mass times velocity squared. And the standard units to evaluate the equation is joules, which is a unit that we use to define energy in this specific unit. Okay, so moving on to potential energy. Potential energy is basically when the object is still but has the capacity to move. It's not moving like kinetic, like I previously said, but it has the capacity to move. So if this object is still right here, and I'm holding it like this, if I were to remove this, it would fall. It has the capacity to move. But it also depends on a reference point. First, we're going to be talking a little bit more about gravitational potential energy, which is the energy of the object that can move due to gravity. So if this object right here, which is my calculator, it would move because gravity is pulling it down. And in this case, the factors that influence gravitational energy, potential energy, is mass, gravity's acceleration, which is 9.8, and the height from the floor. The mathematical equation for this is potential gravitational energy equals mass times gravity's acceleration times height, which in standard units it's kilograms times mass squared times divided by seconds squared. which, as I said previously, is just a unit for joules. Okay, now that we got that figured out, we're going to be moving on to elastic potential energy.